not try this at home? Saw this on Facebook. They had a lot of advertisement for it, and I wanted to look at it and do a little review. If I can find my meter, measure the wattage and whatnot, I might have to go buy another one if I can't find it. But I want to take and measure the output and see if what they say is true about how many wattage it puts out and charging and all that. Anker, that's how I say it. Charge fast, live more. And it's supposed to be smaller than your common charger. I just opened this part here. I haven't opened the rest of it. Got this off of Amazon for like $16.95 or something like that. The model number is a2633. Fast charging via leading technology. I'm gonna open it. Made in Vietnam. Huh. This is the front. You pull the tab, but it's backwards. Okay. Are you happy? Well, I'm not sure. IQ3. It's a USB-C charger. It's got some weight to it. I want to take and get an iPhone charger and compare it in size, because they kept talking about the size of it. 3 amps to output, 5 volt. This will pop out, or yeah, this side here is going to pop out. Let me go get an iPhone charger and we'll compare the size. There's no polarization. Both sides are the same, so you can plug it in either way. Okay, so here is an Apple charger. You know, I should see, designed by Apple in California. It's a little bit taller. Appears to be a little bit wider. And that's only because of the round of the face. Apple Chargers has 1 amp capability, and this is 3 amps. Let me see if I can find my kilowatt meter, and we can measure the output of this to see if it has a higher charging rate and that sort. In the meantime, we can look and see what the happy pamphlet is. Happy, 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 not happy, happy. Okay, just a card. Oh, happy. We're just happy that you're happy. If you know how to express your newfound joy, we found a few suggestions. Tell your friends, family, share, write a review on Amazon. If you're not happy, so work hard, got a smile on your face. FCC, blah, blah, blah. Been tested. So this equipment generates, uses, and can radiate radio frequencies, energy, and if not installed and used according to instructions, may cause harmful interference in radio communication. So, I don't think that means it has any UL testing or anything like that. I could be wrong. For fastest charging, safest charge is an Anker cable. Which would have been cool if they included that for $17. This product is designed to use for IT equipment only. What else can you use it for? Power supply is not intended to be repaired by service personnel in case of failure or component defect. The product can be disposed of. Well, that makes me go, We'll find the kilowatt meter. We'll plug a phone in that's been completely dead. Of course, I have to now find a cable that fits it. And we'll do a comparison. And then we'll open it up and see what's in the inside of this. Now, I did a misrepresentation of that because this is a USB-C 3-amp charger from Apple, and that is much, much larger. Here's the cable. So, yeah, I can see the difference. Now, if this is actually legitimate, and I know that this doesn't charge a phone any faster than the other. So, here's a phone, and it's completely dead. We will plug it into this. I just want to see how quickly it'll bring it up. So right now we're at 5.1 watt. This is the phone that I've been charging before. You can see that its battery is low. Amperes is 0.08, and that is using this charger at the battery being dead. We'll switch over to the Anker. Here's the Anker. 0.09, 0.10 amps, 5.9 watts. This is the same. Now we're up to 6 watts. Now I realize this is just measured on the AC side, what the draw is of the whole thing, so the wattage will be a lot different from what they say, like what's versus AC versus DC for wattage and that sort. So as it's just sitting here charging, not being used, it only uses almost 6 watts. So that thing is, fluctuating a lot versus this. And I'll take and put it back so you'll see. Back at the regular Apple one. 5.3. So it's going between 5.3, 4, to 5.1. It's not going up above 6. Now we have the screen is on. It dropped down to 3 watts, I just saw there. What I just did was take and pull this up here. And I'm going to do the same for this side. Try to get this side shell undone. Kind of interesting. I don't see any wiring, which typically China loves to just take solder a thin wire from here to here, and they call it good. In reference, this is what I mean. They're taking solder 2 wires there and solder right onto your circuit board. So they have a piece of tape or something. I probably could have just popped it out without heating it up. Okay, so there's the wiring. Looks like the circuit board. Oh wow. I didn't do any damage, so that's good. Okay, so it's what you see, what you get. That's really interesting. It's got to be a transformer or coil here. There's your bridge rectifier. What kind of flux? This part number here is ALM9Q6436, I think is what it is. There's a number above it, but the other one's larger. I'll have to take and look that up, see what that is. Couple capacitors. Sam Exxon. Well, those are completely... They may be better today, but these are not good quality capacitors in my opinion. A MOSFET here. That's what that is. Not sure what this chip is. Some hard silicon glue there. So let's take the tape off. How did I do this? Oh, so I broke the main power wire off. There's your main power right here. Boop. Yep, I just broke that wire right off. Okay, so we will take a cheap one apart here. I'm going to do some researching on that chip there and see what some of these other parts are. Kind of come back and be like, is it capable of 3 amps? Maybe. Should you run 3 amps? Probably not. Look at that. Right on top of that resistor they cut off and soldered there, whatever component that is. Kind of weird. Soldering job, for the most part, that I can see, is okay. This one right here, it could be free floating a lot better than that. But for the most part, it looks okay. These capacitors are taped. They have the polyamide tape on top of it. Same way with this. So they put some thought to that. That's good. I can heat this board up and separate the two. And I'll never be able to use it again, which is fine. I may not be able to separate it completely because we have this glue here that's kind of hard that's attached to both sides. So I'm going to leave it as is for now. I'm going to look this chip up and some other parts. And I'm going to take another board apart. A little charger. It's not any brand, but cheap Walmart brand. It costs $4.68. Okay, so I have not had any luck looking up these parts whatsoever. I did find this pretty cool. There's this thing here. It has silicon saw. They're covering up a capacitor. It's an aluminum capacitor. So it's usually a low ESD capacitor that they have like that. Versus these are just like power filters. So it'd be on your output side of your bridge. So that'd be okay for that kind of stuff. Eventually they'll fail. And this is here for more of your controlled voltage. Most MOSFETs like this, most of the time it's 10 amps or higher. This would be your controller chip that would pulse out. So, yeah. I did not have a way to take in monitor the power on the output, and we noticed everything was fluctuating. We can take and try to do that, but I would have to take and find on the circuit board where the 5 volts would be, and then ground would just be like one of these guys here. I don't want to take and totally cut up my cable just yet. I have other things I'm going to do with it, like charging my phone. And yeah, it would be interesting to see if the voltage, like the current and the wattage, was going constantly up and down. It would be interesting to see if the output of this voltage was constantly going up and down as well. If that would be the case, to me that would suggest that it's not the greatest thing for your phone. It should have a nice steady voltage. I'm guessing that it's a pulsating, usually like a square wave, and I'll have to take a measure of that out. I do have a voltmeter. And it's a fluke, so it's not just a crappy brand from Walmart. And we'll take and measure that. This chip also handles up to 3 amps. So that could possibly be why they can do that. Why it's rated for 3 amps, because that's rated for 3 amps. That's just a speculation. Yeah. Now I have the power off, so I wanted to make sure nothing blew up when I first plugged it in. Okay, good. Now what I want to do is take is measure, and I got to be careful I'm not touching these the board here. It's just nothing you need to do at home. I wanted to see the cross this capacitor, and the bridge here would be your positive and negative. It should be about 168 volts DC, and that's what it is. I just wanted to kind of sit there and see what it measures. I mean, it's not tight. But with your AC is going to be fluctuating as well. Some. Not too bad. It should have enough So that's not too bad, I don't think. And let's see, where was the other one? You have this capacitor, you have another one next to it. I think it's this pad here and here. But I'm going to try measuring. It's also another 400 volt capacitor. I believe it was 12 microfarad. I will see what happens. That's obviously not it. But it has to be. Interesting. Oh, it's just it right here. If it's smaller than what my eyes are seeing. And that's not it. Anyway, we'll move on. I want to take and measure that silver capacitor. It was on, they had the heat shrink around it. It's on this side, which I put hot glue on, so that's nice. It's awesome. I did that. I want to see what the voltage is going across it. 4.96. That's steady. That's great. And I'm gonna guess that this is ground and this is positive. Yep. So I can now go on I don't know if it's right here of this capacitor. Nope. I don't imagine VDD is going to be much different. But I can't tell. But yeah, that's a steady. It's just a phone charger, that's all it is. I mean, it's not like it's so much great technology or whatever. They just package a bunch of stuff in there. I still don't know what this chip here, what its functionality is. But, I don't know. And I always take and measure the voltages from ground to each pin. That's 4. I mean, that was 5. And I don't know if that is output or what it is. Okay, on the bottom here, you'll see a bar graph. In DC, we don't want to see pulsating. You can see that it's pulsating a little bit. Kind of makes me wonder if they have this like a square wave or a sawtooth or something. I had to hook up a scope to it and be able to see, and I don't have a scope. If you order 5,000 pieces, it's still 75 cents. So there's $2 in parts here, basically. This is going to be another buck. So I can understand why they charge you $16, and they have a lot of money in parts that make it work good. And then you skimp out on these 3 cheap-ass capacitors. I also kind of wonder what's going on with this here. Why is it such a blobbity blob of solder there right underneath your name there, Anker Anker, is that how you say it? I don't know. Overall, you're getting your bang worth of your buck. They're not making much money off of this. So let's review. Does this take and charge your phone 50% in half an hour? Yes. Will this do the same? Sure. Yeah. About the same. Probably. I haven't tested it. Is there anything benefiting to buy something like this? Probably costs. I'm sure this costs more than $16. And size. They package a lot of stuff in that thing. Where this is probably, I'm guessing, a lot less. I could be wrong. This weight's about the same. It's a little bit heavier. So, is it worth the $16? Yeah, that's totally up to you. When I charge my phone, usually I just have a crappy $5 one from Walmart. And I charge my phone at night, so I don't really notice how long it takes to charge. But if you're on the go and you want to take only an hour to charge your phone, this is perfect. Fit small places, pocket and whatnot, versus something that's bulky like this. So, pretty cool. Thanks for watching. That's all I have to talk about. I'll see you next time.